and we say that A1, and maybe I want to go fast here, AK goes from 1 to n is a subset of Rm. What does it mean to be a subset of Rm? Every single one of those is in Rm. We say the set A1, A2, all the way down to AN is linearly dependent. So the set is linearly dependent. Could you guess when we say the set is linearly dependent? Is each vector, so like in this set, would you guess A1, A2, A3? Do you think that's linearly independent set or a linearly dependent set?
Depends on what?
Yeah. Is linearly dependent. If and only if we can write A sub j equal to x1 a1 plus plus xj minus 1 aj minus 1 xj plus 1 aj plus 1 all the way down to what? For some scalars x sub k in R. What's the claim there? When is a set of vectors linearly independent?
We can use to represent one vector as a sum of color vector.
Let's think about it from this context. So we're going to get back to that. When is a single vector linearly dependent on another set of vectors? Yeah, so we said in this case, A3 was linearly dependent on A1 and A2. Why? Because you could write A3 as a linear combinations of A1 and A2. Now let me ask you this. What about the set A1, A2, and A3? Is that set linearly independent or linearly dependent from this context? Why is it dependent? Because one of your vectors can be written as a linear combination of your other vectors. In other words, the vector that is dependent on your other ones adds no new information to your span. It includes redundant information with respect to the span, with respect to linear combinations. Yeah, Joe.
A4, and A4 was independent of 1, 2, and 3. We would still have a dependent set because 3 is still dependent
Yep.
on 1 and 8.
So we're going to say that this is what we're going to call a linearly dependent set, since A3 is linearly dependent on what? On 1 and 2. Is that the only option that you had? No, try this one. How would you write A2 as a linear combinations of A3 and A1? Yeah, what if you did this? 1 times A1 minus I guess you would do plus 1, right? Because this would be what? 1 times 1, 1, 0, 0 plus 1 times, this was 1, 1, 1, 1, right? Sam, your facial expression made me feel like I was out of my mind there, right? Am I okay there? Yeah, so now this would be 0, 0, negative 1, negative 1, but that was exactly A2. And you will find this to be true. Generally, if you have a linearly dependent set, there are many linear combinations where you can isolate one from the other ones in the set, right?